Okay, YouTube, in this video we're going to talk about what a matrix is, or what is a matrix, really. And basically, when we talk about matrices in math, we're really just talking about a rectangular array of real numbers, of course. And I'm not saying you can't have imaginaries in here, but we just basically say it's a representation of values in a rectangular fashion such that we have rows and that we have columns, okay? So things that we want to say about matrices. First one is this, that we always, when we write arrays of numbers, or these matrices here, we use brackets. So we say brackets indicate a matrix, indicate matrices. And of course, matrices is the plural of matrix. I know that some people argue about this, but I don't. So this word, for example, be a symbolic representation of the matrix A here, and perhaps I'm calling this the matrix A. So another thing I want to say about this is you notice that I call this A, I could have called it B, I could have called it C, D. You pick your letter, but basically I'm using a capital letter. So we use capital letters to represent matrices. Letters to represent matrices. So along with this rectangular array here, you know I mentioned rows and columns. We're going to get this straight right now, but we say columns are things that are vertically oriented. Whoops, columns. And we say that these are these things right here. And we actually have two columns on this. And in terms of rows, we say that the rows are 3 in number. We have these 3 right here. So in terms of a matrix, we could say any matrix could be any number of rows and any number of columns, even one row and one column. But the bottom line is that we refer to the order of the matrix as kind of like its size, or I could say it's like dimensions, basically, dimensions or size. And so we always do number of rows by number of columns. And so in this case, up here, I'm going to write a little in the bottom right corner, 3 by 2. And basically what this indicates is that we have 3 rows and 2 columns. And it's always rows and then columns here for our matrices. So this would be a 3 by 2. I would say more generally speaking, if we're going to write a matrix A here, we would say that it is M by N, where M is the number of rows here, rows, and this is the number of columns. And the number of rows certainly doesn't have to be equal to the number of columns here, but they will be positive integers, okay? So one thing of note here is if M is equal to N, then we say we have the same number of rows and the same number of columns. So for instance here, if I had A 2 by 2, then what I would really have is this matrix here that has 2 rows and 2 columns. And what I'm actually going to do is I'm going to populate this by writing in these little a's here. So we have A11, A12, A21, A22, and this is a 2 by 2 matrix. So these are the same matrices, but what you'll notice is that symbolically, when we write a lot of formulas or go over theorems for matrices or laws, we basically represent them more generally as a matrix here full of little a's, if this is a capital A, and every little a here is what we call an entry of the matrix. And so each entry is just one of these numbers that's in the matrix, and this little subscript here, the first number indicates the row that you're in, and the second number indicates the column that you're in. So for instance up here, if I were to say what is the value of A32, then what I would be acknowledging is that we're in the third row in the second column. It would be this value right here. I just say it's equal to 4. Okay, so all matrices are these rectangular arrays of numbers that we represent with capital letters, and we use brackets around, and it's just a collection of numbers in rows and columns that's ordered. Square matrices are those that have the same number of rows as columns. So let's talk about why we use matrices, and then we'll piece out of this video. But basically, we say that a matrix derived from a system of linear equations we refer to as an augmented matrix. And because we're so interested in solving systems all of the time, what we're going to do is we're going to write a matrix that is corresponding to this right here. And we're going to refer to it as its augmented matrix. So the way this looks is essentially this. We're going to say we're going to have as many rows as we have equations, and we're going to have as many columns as we need to fill all of these here. So what we're going to look at here is something where we're going to omit all of the letters, and we're just going to put in the values. So I'm going to write 1 is the coefficient of x, -4 is the coefficient of y, and 3 is the coefficient of z. Down here I'm going to write -1, 3, and -1. And for my last equation, I notice I have 2 as the coefficient of x, no y. So we're going to fill this in with a 0, and then we say -4 these z things. Now what makes this an augmented matrix is sometimes you see a colon right here. You'll write colons. I'm kind of a lazy guy. I just write a little line right here, a little bar. But we're going to write the constants in over on this side. And so I would say that what an augmented matrix is an adjoinment of 2 separate matrices here that we're going to give names. And we're going to refer to this as the coefficient matrix containing all of the coefficients. This is imperative knowledge later on down the road. But for right now, I want you to know that an augmented matrix for a system is just joining these two matrices together, where you can see that I get this matrix right here. We're going to call this the constant matrix because it contains our constant. And then over here, we're going to call this the coefficient matrix because it contains all of our coefficients. So this is our coefficient matrix. And you'll notice that this is a 3 by 3 and that this is a 3-row by 1-column matrix here, or what we call a column matrix. So when you adjoin these together, we get what is referred to as an augmented matrix. And our goal in the grand scheme of things with our matrix math is to be able to reduce this into row echelon form or reduced row echelon form to find solutions to the system here. But you'll notice that it's a lot more streamlined to just write the values here in terms of coefficients and constants instead of writing all the letters that go with it constantly. So in the next video, we'll look at our row operations. Cheers.